All right, so the first and second questions say to put the function in standard form, which is to complete the square, and then find all that information out based on your standard form. So for number 1, I'm going to take out the 3. I'm going to group these together. Take out the 3, and I get x squared plus 5 over 3x. Leave this space plus 1. Then I need to find b, so I'm going to find c, sorry, 5 over 3 divided by 2, and then square it. So that would be 5/3 times 1/2 squared, and that's 5/6 squared, which is 25 over 36. And I'm going to add that inside the parentheses, and I would normally subtract it from outside the parentheses, but I have to multiply by the 3 that was taken out first. So then that 3 goes into the 36 12 times, and I'm subtracting 25 over 12. I'm going to go back and do that in a minute. So h of x would equal 3 square root the x squared, you get x, square root the 25 36, which is 5/6. Take the sign from the middle, put it in parentheses, and square it. And then I'm going to combine these together. So positive 1, which becomes 12 twelfths, minus 25 twelfths is negative 13 twelfths. And there's the standard form of my equation. From here, you can get the vertex by taking the opposite of what follows x, negative 5/6, and then the k that's on the outside, you keep that sign, negative 13 twelfths. Your axis of symmetry is x equals the x value, which is negative 5/6. Your domain is an easy one because it's a parabola, it's all real numbers. And then the range, this parabola is going to open upward because it's a positive on the front. So it starts at k, which is negative 13 twelfths, and it goes to positive infinity. The y-intercept should also be easy from the beginning quadratic form. This would be 0. This would be 0, which means all that's left is a positive 1. So when x is 0, y is positive 1. So then I'm going to go to my graph, and I'm going to plot all that information first. Negative 5/6 and negative 1 1/12 would be there. My y-intercept is 0, 1, and I can reflect that. So if you went up your axis symmetry, we went to the right, that 5/6, you can go to the left, that same distance, and plot the other point, and then draw your parabola. So I do know this has x-intercepts. They're not whole numbers, so I'm going to find them. It's easier to use the quadratic this time on the beginning than use the even root on this because it's fractions, but you can do both. So if I wanted to find the x-intercepts, A is 3, B is 5, and C is 1. And I get negative B plus and minus the square root of B squared minus 4AC all over 2 times A. Negative 5 plus and minus the square root of 25 minus 12 over 6. Negative 5 plus and minus the square root of 13 over 6. That doesn't simplify, but when I write my intercepts, I want to write them in coordinate point form. So negative 5 plus and minus root 13 over 6, comma, 0. Now, if I want to approximate them to see where they would fall on the graph, I would say that the square root of 13 is in between square root 9 and square root 16, so like maybe a 3.5. Negative 5 plus 3.5 over 6 and negative 5 minus 3.5 over 6 are my two decimals. So this is like negative 1.5 over 6. And that's going to be like a 1/4. So put like 1/4 or 0.25. And then this is negative 8.5 over 6, which is like a negative 1.4. So when we look to the graph, this actually should have been, this is negative, sorry. This should have been my negative like 1/4, and then this would have been my negative 1.4. So it's consistent with what we drew on our graph. Again, I would recommend saving that approximation till the end, work through everything, use your y-intercept to reflect it, get your graph, finish the questions, and then go back and approximate those x-intercepts to make sure. All right, I'm going to do 2. So same set of instructions. The f of x is going to equal, group them together, negative x squared plus 2x plus 9. Take out the negative, negative x squared minus 2x plus 9. That negative changes. When you take it out, it changes the sign on the 2x. Take the 2, divide it by 2, and square it. I get 1 squared, which is 1. Add the 1 here. Normally, we subtract the 1 from the 9, but I have to multiply by the negative 1 on the front, which now changes this to add 1. So I get f of x equals negative x. So I square rooted the x squared. I'm going to square root the 1. I take the sign from the middle, which is negative, put it in parentheses and square it. And then positive 9 plus 1 is positive 10. Here's the standard form of my equation. My vertex is the opposite of what follows x, so 1, and then the k on the outside, keep the sign, that's 10. Your axis symmetry is x equals the h, which is 1. The negative on the front this time means this parabola is pointing down. So while my domain is negative infinity and to positive infinity, and that didn't change, the range is going to go from negative infinity up to the k, which is 10, with a bracket on that 10. My y-intercept, I want to go back to my initial equation, 0 out the x's, and I get 9. And I'd start by plotting that. 1, 10, if I go by 2's on this graph. Would be here. And my y-intercept being 0, 9 is here. I know this points down, so this is also going to have x-intercepts. And to find them, this time it's not so bad to get them from my standard form. So I'm going to use that even root. I would get 0 equals negative x minus 1 squared plus 10. Subtract the 10. Divide both sides by negative 1. Square root both sides, putting that plus and minus in front of the root 10. And then add the 1 at the end. And I get 1 plus and minus square root 10. So again, I'm going to keep it exact when I write it as my x-intercepts, but I would approximate it to check my graph. So I can just reflect the y-intercept to get the graph at the top, and I can also do 1 plus and minus. That's like a 3.1. 1 minus 3.1 would be negative 2.1, and 1 plus 3.1 would be 4.1. So it'd be here and here, and it would complete my parabola. All right, 3 and 4 say to use negative b over 2a to find the vertex, and then the rest of it. So instead of putting it in a standard form, this time your a is negative 2, your b is negative 7. Negative b over 2a means change that sign, so it would be a positive 7 over 2 times negative 2. And that's 7 over negative 4. So that's the x-coordinate of your vertex. I have to plug it back in to get the y. So y would equal negative 2 times negative 7/4 squared minus 7 times negative 7/4 plus 5. And then negative 7/4 squared is 49/16. Negative 7 times a negative 7/4 is positive 49/4 plus 5. 2 goes into 16 8 times negative 49/8 plus 49/4 plus 5. Now I got to give them each, the 8 is the denominator, so I'm going to multiply by 2 here and 8 here. Negative 49/8 plus 98/4 plus 48. This should be 8. So then I get a positive 49 over 8 plus 40 over 8, which is 89 over 8, and that's the y-coordinate of your vertex. When we go to graph these on the coordinate grid, we're going to need to convert them to mixed numbers. So negative 1 3/4 and 11 1/8. Now my axis of symmetry is x equals negative 7/4. Domain, all real numbers. Range, this opens downward because of the negative. So negative infinity up to the y, which is 89/8 with a bracket on that. And the y-intercept, I would zero out these x's and I get 5. So I'm going to graph that information first. The negative 1 3/4 and 11. So I'm going to go by 2's again. 2, 4, 6, 8, 10, negative 2, negative 4. So negative 1 3/4 and positive 11 1/8 is kind of up here. My y-intercept is 0, 5. I can reflect that. So I went to the right. I can go to the left the same distance. And it is going to cross through my x-axis, so there should be x-intercepts. Now to find them, I'm going to use quadratic on my original equation. So it's A is negative 2, B is negative 7, and C is 5. So negative B, which becomes positive 7, plus and minus the square root of B squared minus 4 times A times C all over 2 times A. 7 plus and minus the square root of 49. That's a positive 8 times 5, so positive 40 over negative 4. Square root 89 over negative 4. 89 does not break down, so that is my x value, and then I would put 0 as the y, and that would be your x-intercepts. And that would be hard to approximate to test it out, but you can. You would approximate like root 89 to be like a 9.2 or 9.3, and then go from there. But again, instead, I would just reflect that y-axis or the y-intercept over on the left to make your overall curve. All right, 4, same set of instructions. So A is 4 and B is negative 3, and the H would be negative 3 over 2 times 4, which is 3/8. That's the x-coordinate of your vertex. Plug it back in. This is 9/64, 9/8. This goes in here 16 times. And I have 9/16. I got to change this denominator. 18/16 and 32/16. So negative 9/16 plus 32/16, which is 23/16. And that's the y-coordinate of your vertex. So now we've got our axis of symmetry. X equals 3/8. This is going to open upward. Domain would be negative infinity to positive infinity. Range is going to be from the k, which is 23/16 to positive infinity. If we zero out the x's, we get the y-intercept, which is 0, 2. So if I start with that information, my 3/8 and this 23/16 is 1 and 7/16. So 3/8 and 1 and 7/16 is about there. My y-intercept is 0, 2. And this time I'm going to go 3/8-ish to the right. And my parabola points up. So from the graph, I can already tell that there are no x-intercepts. Should I do the work for the x-intercept, I would do the quadratic here. Negative b plus and minus the square root of b squared minus 4 times a times c over 2 times a. And I'm going to get a negative number underneath my radical, which is why there would be no real numbers, so no x-intercepts. Looking at number 5, it says find the standard form of the equation if the vertex the vertex is negative 2, 3, and it runs through the point 3, 5. So this is my x and this is my y, this is my h and my k, and I'm plugging into y equals a times x minus h squared plus k. So the y is 5, the a we don't know, the x is 3, the h is a negative 2. So minus the negative 2 becomes positive 2, squared, don't forget the squared, plus 3. 5 equals a times 5 squared plus 3. Subtract that 3. 2 equals a times 25. Divide by 25. And a is 2 over 25. And then we take and plug back in the a, the h, and the k. So y equals 2/5. X minus the negative 2 again, so plus 2 squared plus 3. And then there's your equation in standard form.